Hello everyone. So here is the class about the previous questions of IIT JAM which are covered for the last 15 years I hope. So this topic here we're going to consider the 20 questions or around 20 questions which are came from the electronic displacement topic. Okay. So electronic displacement topic. So this question is from IIT JAM 2005. Here it is asking about the decreasing order of the acidity of hydrogen indicated in italic. Okay, so this is what underlined one is asking for the acidity. Okay, so underlined hydrogen. So if I consider this is a acetone molecule, okay, if I consider this is a acetyl acetone, okay, so this is a ethyl ester acetate, this is nitroacetone. Okay, so give me a minute. So if these molecules are given, the acidity of the H plus or of a molecule is going to directly proportional to the stability. So these are the hydrogens. So once it got liberated or H plus eliminated, the anion which is generating must be most stable so that it can act as a best acid. Okay. So after elimination of H plus, each of the molecule is going to become carbon ion. So these are the carbon ions. Now the carbon ion attaching to the strong withdrawing groups, okay, strong withdrawing groups will be most stable so that acidity will be highest. Okay, so in withdrawing nature here it is given nitro, which is a best withdrawing group. Okay, then ketone, okay, C double bond O CH3. Okay, then ester, C double bond O OCS3. Okay, so this is the withdrawing nature of the molecules of the groups. So highest stability will be with nitro, okay, and with ketone. Okay, so if any molecule is there, this is with ketone, this is also with ketone, two ketones, and this is two esters, and this is with one ketone. Okay, so having two withdrawing groups, from that most stable withdrawing group, most supporting withdrawing group is NO2, so 4 will be the first. Okay, then two withdrawing groups which are two aldehydes, then this will be the second, then this will be the third, this will be the fourth. Okay, so the decreasing order of the acidity is 4, then 2, then 3, then 1. So which is the answer? 4, 3, 2, 1. This one. Okay, so option B is correct from this. Next, benzyl chloride. Okay, so benzyl, so it is benzyl chloride, this one. Benzyl chloride is reacted with the different nucleophiles shown below. Arrange them in the decreasing order of the reactivity. So a nucleophile means it is having electron excess. So the more is the electron excess nature, the more will be the nucleophilicity. That is what nucleophilic character. Okay. So nucleophilicity is directly proportional to the electron density. Okay, or you can consider anion if it is with more stable with less nucleophilicity, if it is with less stable more nucleophilicity. Okay, so inversely proportional to the stability of anion. Now consider you have given methoxide, phenoxide, acetate, and hydroxide. So among these all, this is going to stabilize with the conjugation, and this is also, but this is equivalent conjugation, which is even more stable. Okay. Next, this is with no stability or no instability, but a donating group attached to the anion will be going to decrease the stability. So this is with the least stability, most nucleophilicity. So acetate, methoxide, then hydroxide, then phenoxide, then acetate. Methoxide, hydroxide, phenoxide, acetate. So option A is correct. Okay, you might be able to find the different questions, yeah, with your efforts, but the thing is you can't find anywhere solutions. Is finding is difficult. So here I'm giving all the solutions with the explanation, which is I think nowhere you can find the video like this. So utilize it. Okay, so that clarify your concepts, and try to work out on more questions. So correct dipole moment of the following. Okay, so dipole moment is what being pole are being generated the two poles. Okay, so from a molecules, it's going to become negative and positive poles. Okay, so thing is when it is aldehyde, oxygen is there, it's going to create, or it's going to pull the electron density towards one side. So it can generate the polarity. Okay, it can generate the polarity. So O minus will become, and C plus will become. Okay, so by the delocalization or by the displacement of the pi bond. Okay, so if it is conjugated, it's going to polarize even more, so that positive and negative will be going to generate from the throughout the molecule. Okay, so if it is double bond, carbon carbon is double bonded, so little bit symmetrical. Okay, both the effects are same, but this is donating group which is attached, so it can become the negative and this can become the positive. Okay, so here oxygen attached systems will be with more dipole moment, and even if it is conjugated, its dipole moment is going to increase, so that anions and cations that's going to generate will be stabilized. Okay, so the mu2 will be the maximum, then mu1, then mu3. Okay, so mu2, mu1, mu3. Option D is correct. Okay, here nothing is there. Oxygen attached system or carbonyl systems are polar systems. Olefin systems are less polar systems, and carbonyl, which is with conjugated, will make the molecule into the more polar way. Okay, more dipole moment is going to happen by the conjugation, so that molecule is going to exist with the positive and negative pole. Okay, that's the logic. So next, the compound which can react with aqueous sodium bicarbonate and release carbon dioxide. So it is being asked for the acidity. Okay, acidity. So generally carboxylic acids are more acidic, so that they can react with bicarbonate. Okay, so this is the logic. So when it is most acidic and this is weak base. Okay, so if a weak base must be reacted, means it must react with a strong acid. Okay, so among these, which is strong acid it is asking. Okay, so after carboxylic acid, generally we find the phenols are more acidic. Okay, and then alcohols, which are less than the water. Okay, this is the acidity trend. So only carboxylic acid can react with sodium bicarbonate and release carbon dioxide. Okay, apart from the carbon dioxide, when it is ene diols. Okay, ene diols, they are also highly acidic, so that they will react with the sodium bicarbonate. So phenols are little bit less acidic when compared to the ene diols, because once ene diol is forming, acid is more acidic because of the equivalent conjugation. Okay, equivalent resonance. Okay, so this is what equivalent is. The same thing is going to happen if it is diol is there. If it is gets liberate H plus, it's going to become, okay. So or it can move towards this. Okay, so this is specific system which is going to give a particular equivalent conjugation. Okay, so if I write the product conjugated structure, so this got negative and this got double bond, and this is as such, and double bond is here. So exactly similar. Okay, exactly similar. So this is called again equivalent conjugation or equivalent resonance, which equally acidic as the carboxylic acid. So among these, this is one such acid which is going to react with sodium bicarbonate, and this is also another one which is very similar to the diol systems. Okay, so this gets negative. Okay, so 2 and 4 are the most acidic. Why not phenols and why not alcohols? Phenols and this is alcohol, 3 alcohol system, no phenol. This is phenol system. Phenols and alcohols are less acidic as compared to the carboxylic acid, so that they are not readily going to react with the sodium bicarbonate. Okay, next, correct statement describing the relationship between the x, y, and z. Okay, so x, y resonating structures and z is tautomer. So let's see what is the difference between the resonating structures and the tautomers. So can be considered a tautomer can be considered as a hydrogen transfer, H plus transfer systems. Okay, where there is a H plus displacement is going to happen around the pi bond. So if I consider these two, if it is migrating from this to this, it's going to generate this. Where there is no H plus transfer, it is not a tautomer. Or H plus difference or H plus position different having molecules are called tautomers. So other than that, if a charge distribution is going to happen, they are said to be resonating structures. Okay, so here charge is going to distribute from one place to other place. Okay, so this is resonating structure, these two. And if I consider tautomer for this, when H plus gets shifted to here, okay, and that H plus is going to become H plus. If it is acquired, it's going to give this. Okay, so this is called tautomer. Okay, this is called tautomer. Even it is also possible. So if H plus abstracted and the bond from this is migrated to this, so this is also tautomer. So these two can give the tautomers for the Z, but not X and Y are the resonating structures. Okay, so option A is correct. Okay, so if you're not able to understand, just go with the tautomers definition and resonance structures definition, so that you will be able to understand. Okay, so next question, correct the acidity among the given compounds. So what is acidity? Acidity is the H plus donation capacity. Okay. So here bases are given and asking for the H plus donation. How it is going to come? So let's make a relationship between acidity, basicity of these molecules. Okay. So let's say I'm going to find the basicity of these all molecules before they accept the H plus. Okay. I'm removing H plus. So it's going to become this is pyridine and this is pyro and this is N-methyl, sorry, aromatyl pyridine and this is pyrrolidine. Okay. So let's have a look at their basicity. So basicity of the non-conjugated systems are more when compared with the conjugated system. So this is one. Okay. This is the highest basis. Okay. And next, in conjugated system, where the lone pair is available, will be more basic when compared to lone pair is involved in the resonance. So these two will be more basic. Okay. Among these, if it is electron donating group is attached to the ring, it's going to be more basic to this one, the last to this one. So basicity means subtraction of H plus. So if I given H plus, it is going to acquire first. Automatically, the more basic will be going to acquire. So it's going to become. So a base which after abstracting the H plus, it becomes the conjugated acid. So here is what the question. These are become conjugated acids after abstracting the proton. So here it is asking for the acidity only. So as they are acid, it is being asked for the acidity. But the thing is, when a base if it is strong, the conjugated acid which is forming will be weak. So the basicity is more, acidity will be less. Okay. So if you need to find the more acidic one, you need to find the least basic one. That is what this. So 2 highest. Okay. Then first, second highest. Then third, third highest. Then this is the last. Okay. So acidity trend will be in this way as reverse to the basicity. Okay. In another term, you can find the least basic one as the first one. Then decreasing, increasing the basicity, decreases the acidity. Okay. So this concept is very important. A strong base is going to release a weakest acid. Next one. The reactivity order of the indicator functional group shows a nucleoside. So here it is given the points carbonyl carbon. Okay. If the carbonyl carbon attached to the more withdrawing group, okay, then it is going to be more electron deficient. So it will be attacked by the nucleophile faster. Okay. So reactivity will be more if it is attached to the more withdrawing group or more electron withdrawing element or more electron activity element. So among oxygen and nitrogen, oxygen will be more withdrawing in nature, more electron active. So once it gets attached with ester or another oxygen, it will be in the conjugation so that its electron density is going to rise up. Okay, so deficiency is going to decrease. Okay, so this will be the least reactive. So among nitrogen and oxygen, oxygen will be more electronegative, and moreover this is not attached to the donating loop. So this is highly reactive. P, then Q, then R. Option A is correct. Okay, next. Uh, Here it is asked about the hydrogen indicated in bold acidity. So release of this H plus. So once it is asking for the release of H plus, you need to see only the thing anion formation. Anion formation. Once it is anion is forming, how stable it is, you need to see. Okay, how stable it is. That's the point. So here it's going to become anion, so that it will be conjugated between the two rings. Here if it is gets anion, it's going to conjugate it between the three rings. This is a separate ring. Here if it is gets anion, it's going to stabilize between the three rings which are in one plane. Okay, so a complete planar system is going to generate, which is very near to each other. Okay, so this is going to be more stable. Okay, then this R, Q, and P. Okay, these two are one and the same with three rings, but the thing is more stability because all are in one plane. Okay, so conjugation will be extended if it is a planar or if it is in single plane. Next, it's a simple question. Which of the following is aromatic? So this question is asked in 2009. Okay, so aromaticity is depends on the Huckel rules. So four Huckel rules are there. One, compound must be cyclic. Second, planar. Third, conjugated. Fourth, 4n plus 2 pi electrons should be there. Okay, so all are cyclic. Okay, planar. So if it is sp2 and sp carbons are there, they are planar. Okay, if it is sp3, it must be charged or it must be lone pair. Okay, otherwise it's not a planar. So this is with sp3 carbon, so not a planar, and rest all will be the planar. All are this is sp2, this is sp3 but involved in the conjugation. This is sp3 but involved in the conjugation. Whenever it is sp3 and involved in the conjugation with the negative charge or lone pair, then they are also planar. Okay, so conjugated, all are conjugated except this. Okay, 4n plus 2 pi. So this is one ring, so 4 into 1 plus 2, it is 6 pi should be there. So this is 2 pi, 4 pi, 6 pi. It is aromatic. This is 2 pi, 4 pi, 6 pi, and this is 2 pi. So 8 pi. It is anti-aromatic. Okay. So this is 2 pi, 4 pi, and 6 pi. This is aromatic. So Q and S are aromatic. Okay. It's a simple question. Next. This question is asked in the 2012. Okay. So nucleophilicity of the following anions in SN2. Okay. So SN2 are in any nucleophilic substitution reaction, nucleophilicity is nothing but electron richness. Okay, electron richness. The more is the electron richness, the more will be the nucleophilicity. Okay, the more will be the nucleophilicity. So P, Q, R, and S Among these, R and S are attached with the withdrawing groups, so they will decrease the electron density. So their nucleophilicity also decreases. Okay, if it is with electron donating groups, it will be increases electron density. Okay, so oxygen and sulfur, these three are with oxygen with the withdrawing groups. This is sulfur. So among oxygen and sulfur, oxygen which is with more electron activity. So when it is uh, more electron negative, it cannot donate much electron density. So sulfur will can donate more electron density, so it will be a good nucleophile. So this is the first. Among these three are with oxygen, these two are with withdrawing group, so this will be the second. And this is with two withdrawing groups, this is one withdrawing group, comparatively more electron rich. So this one, so Q, then P, then R, and this. Okay, so these are the first 10 questions. So here I'm going to release a series of previous questions. So be in touch. So hope you enjoy. Thank you.